Now I have an example that uses exponential decay. A paddock is contaminated with strontium-90, so that's a radioactive substance. It has a half-life of 28 years, meaning that it halves every 28 years. Let M0 be the original mass of strontium. Now, if we've got something that's becoming less over time, then I know that we've got a basic formula that says the amount that we're going to have is going to be to a negative. Now I've chosen to write it this way so that k will be a positive number, but I need to have a negative in front of it. And I know that because it's a situation in nature where we have exponential decay and something's halving every 28 years. So I need to find the mass of strontium as a function of time. In other words, I need a nicer formula for how much strontium there is at any one time. Now, they've told me to let M0 be the initial amount. I'm not going to be able to work out what that is. So this example is a good one for showing you how you can follow through some steps even when you don't know the initial amount. Because the questions that we've got are all finding proportions or percentages of the original value. And we can do that whether or not we know what the original value was. So I do need to find what k is because I can have an unknown here, but I can't have too many unknowns or I won't be able to work out the rest of my problems. So my clue is that we're halving every 28 years. So my first step to find k would be to say, well, what will happen after the first set of 28 years? When t equals 28, isn't the amount that we have half of what we had in the beginning? So this part here means how much have you got now? Well, after 28 years, what we're going to have there is not m, we're going to have half of what we had in the beginning. So I write half of what we had in the beginning is need to be equal to the amount we had in the beginning, e to the minus kt. That's my first step. Now, I don't need to put a t there, I can actually put 28. So multiplying minus k by 28, it would be nicer to write that as minus 28k. Alright, now I can divide both sides by the amount I had in the beginning, and that explains why it doesn't matter if you don't know how much that was, because on the very first line we're going to divide by that anyway. So tidying up now, I've got half is equal to e to the minus 28k. Now there's a number of ways that you can move along from here. I can see that I've got 1 over something there, and on this side I've got a negative index, so I think it might be easiest to actually rewrite the right hand side like this. You could choose to write it as a log straight away and say e to the power of a negative thing equals half. I just think this is going to make it tidier. So no matter which way you did it, it'll work out. But now I can say that the two denominators must be the same. So now I've got a much simpler expression without any negatives in it, which I think is easier. All right, now I can rewrite it as a log and say e to the power of 28k is equal to 2. So then to find what k is, I need to just divide both sides by 28. So I can write it as 1/28th, or I can write it as the natural log of 2 over 28, either way. Now at this point I put that into my calculator so that I can use it later on. But what I really want to do with this k is sub it back in because I need to find a nice formula for how much strontium I've got at any one time. So I would finish off by saying, therefore, m, which is the amount we have at any time, is equal to the amount we started with, which we don't know what that is yet, but that's okay, multiplied by e to the power of negative, in brackets, let's write it as ln 2 over 28, because that looks tidier, I think, and then t. So now I've got a formula that at any time I can put t into and see how much strontium I've actually got. So I'm going to leave this here, so it's up here for the rest of the time while I do B and C. Now moving along to B, I need to find the proportion that remains after 100 years. So, quite straightforward, when t equals 100, how much have I got? Sorry, it's not p, it's m, isn't it? So, after 100 years, I'm going to have the amount I started with multiplied by e to the power of, now I need to do 100 here, so I've got minus all of that, ln 2 over 28, which you may have now already in your calculator, times 100. You can write that a bunch of different ways. Now, this part is straightforward to do, but what are we going to do about the proportion? Well, if you've got something that's unknown, don't worry about it at the moment. Let's just remember that if this now is a nice little formula for what we've got after 100 years, now we can compare that because it doesn't ask how much in overall terms, it says what proportion have you got. So the proportion we've got, well, we're going to have this much, this pen is not great, m0 times e to the power of, let's write that a little bit more tidily this time, minus 100 ln 2 over 28 over, well, how much did we have at the start? At the start we had time would be 0. At the start we just had m0, didn't we? Because summing t equals 0 in here, this whole part becomes 1, and the amount we had was literally by definition this. So as a proportion, I can now divide both of those and they're gone. So how do I get this as a percentage? Because they want it to the nearest 0.1%. Well, no matter what you had, let's just say you had, I don't know, 4/7 of the amount and you wanted it as a percentage, what would you do? You'd multiply by 4/7 by 100. We have this much here and we need to multiply it by 100. So all of this can be put into your calculator now. And what I get when I put that in is 8.4 to the nearest 0.1%. Now, when you get your answer, think through whether or not that makes sense. Would it make sense that after 100 years, I've got 8.4% of what I had? Yeah, it's halving every 28 years. So after 28 years, however much I had in the beginning, I've now only got 50% of that. After another 28 years, I would have half of that, which would only be 25%. And after the third lot of 28 years, I'd be down to 12.5%. Now 100 years is 3 and a bit time periods of 28, isn't it? So it makes complete sense that I'd be down a little bit lower than 12.5%, and this seems right. I wouldn't have gone through 4 halvings yet, so I wouldn't be down to 6.25%, I'd be somewhere in between. So you should always finish by just checking that your answer makes sense. Now for C, we need to find how long it will take for the amount of strontium to be below 0.001% of the original value. So in other words, the amount that we have, or m, we want to find the value of t that will make us have the amount we started with multiplied by this. Now, I'd be tempted to turn that just into a decimal. Percent means out of 100, so I need to divide this by 100 again. So I'm going to have 0.00001. And to me, that just makes a little bit more sense. You could put this in as a percentage if you want to, but I just prefer this. So we're solving for t, so that we write down what you want to do, solve for t, to make this statement true. Okay, so to solve for t, we've got an equation here for m. We want to sub all of that in. So in other words, I need a better pen. Let's go back to purple. m0 e to the power of minus, what have we got, ln 2, natural log of 2t. All of that's on the left-hand side, and I just use my formula. That has to equal the original amount multiplied by my decimal. Now, again, you can see that we can start by just dividing both sides by that original amount. And that's why for these sorts of questions, it doesn't matter too much that we didn't know what it was. Now we can tidy up and say e to the power of this is equal to that. So I'm going to write this as a log. And in fact, there's a few ways you could go here. You could write it as a log just like this, or we could tidy up this index expression and say this is 1 over e to the power of ln 2 over 28t. And this is 1/10th, 100th, 1000th, 10,000th, 100,000th, isn't it? So now I've got that same situation where I can just equate the denominators, saves me from working with nasty negatives and decimals. So now I can say e to the natural log of 2 over 28t is equal to 100,000. Now I can write it as a log. Just makes it a little bit easier. E to the power of natural log of 2 over 28t. And again, you could just call this k the whole way if you wanted to and specify in the beginning what k was. That might make it a bit simpler. Now I've got a large number to fit in there. I didn't leave quite enough space. Now how are you going to find t and get it by itself? You need to divide both sides by this. So then t is going to be equal to, we've got the natural log of 100,000 divided by natural log of 2 over 28. And we can put that whole thing in our calculator and see what the time will be. Now it says to the nearest year. And we get 465.06. So I'll just say 465 years to the nearest year. Now notice that there's a bunch of ways to do your setting out. I chose to use an equal sign here and just see how many years it would take until it was equal to this. Obviously for it to be below it would need to be even more years, but if we're rounding to the nearest year, to me that made sense. So somebody else might have had greater than and less than signs all the way through here. The other thing I did here with my denominator equalising, somebody else might have actually written instead that e to the power of negative all of this is equal to, and then you would have all of this here. Now remember there's a slight pitfall in that if you were doing this method and you've got negative parts there, then if you were using greater than and less than signs, then you've got to be really careful if you're dividing by a negative to make sure you flip the sign. So sometimes working with equals and then just reasoning what the answer means at the end makes a little bit more sense.